Okay, hi everyone. So, good morning. Alright, so today we are going to the last part of chapter 5. Yay! So, we're going to look at subtopic 5.4, phase diagram. And the learning outcomes that we are going to cover for today is first, we are going to define what is phase, triple point, and critical point. We are going to identify the triple and critical point of the phase diagram. We are going to sketch the phase diagram of water and carbon dioxide, and we're going to compare the phase diagram of water and carbon dioxide and explain the anomalous behavior of water. And lastly, we are going to describe the changes in phase with respect to temperature at constant pressure and to the pressure at constant temperature. So without further ado, we are going to start now. Okay, so now let's look at the first part of this video, which is what is phase. Okay, so phase is actually a state of matter that is uniform throughout in the chemical composition and physical state. So a phase is actually homogeneous. So as you know, there are three phases that we learn. First one is solid phase, second one is liquid phase, and third one is gas phase, or we also can call it vapor phase. Okay, dua-dua ni sama saja. Okay, so there are three phases that we learn: solid phase, liquid phase, and gas phase. Okay, so what is phase diagram? Okay, so phase diagram pula. Okay, so phase diagram is a graphical plot of pressure versus temperature. Okay, pressure versus temperature. Okay, so what is the significance of phase diagram? So phase diagram actually shows the condition at which a substance exists as solid, liquid, or gas. Okay, so dia nak tunjuk the condition yang sesuai. So contohlah, kalau at certain condition, substance ni dia exist as solid, or at certain condition, substance ni exist as liquid, or exist as gas. Okay, so dia indicates the most stable phase of a substance exists under different condition. Contohnya, under at 25 degrees Celsius at 1 atm, this substance most stable at liquid phase, for example. Okay, tu contoh dia. So this is what phase diagram shows. Okay, so there are few features in phase diagram or things that you need to aware in phase diagram. So the first one is region, and the second one is line, and the third one is points. So region in phase diagram correspond to the most stable phase of a compound, of a component. Sama ada solid, gas atau liquid. So kita ada region yang solid, kita ada region liquid, and kita ada region gas. Lepas tu kita after this we will look into this part. Okay, and then we got lines. So these lines actually corresponds to the pressure and temperature under which two phases are in equilibrium. Okay, kita ada solid liquid line, solid liquid equilibrium line, solid gas equilibrium line, and liquid gas equilibrium line. And we are going to look at that right after this. And then we have points. So these points, we have 2 points that is stated, that is shown inside the phase diagram that we are going to identify later in the phase diagram. The first one is triple point, and the second one is critical point. Okay, so now let's look at the what is triple point and what is critical point, and then we are going to look at the phase diagram. Okay, so what is triple point? So triple point is a point at which three phases, solid, liquid, and gas, can be in equilibrium with one another at the same temperature and pressure. So maksudnya at this point of the same temperature and pressure, these three state or these three phase, solid, liquid, and gas, exist together in equilibrium. Okay, so this is triple point. So what is meant by critical point? So critical point, on the other hand, is the temperature and pressure at which the liquid and gas can no longer be distinguished. So what does it mean by that? So maksud critical point juga adalah above this point, it is impossible to liquefy a gas no matter how great the applied pressure is. So dekat sini dah tak boleh nak, kan gas kan pergi liquid kan, nanti kita tengok dekat dalam. Okay, so gas kan, if we apply a great pressure, so gas will be liquefied into a into a liquid. However, at this critical point, no matter how great your pressure is applied towards the gas, it will never be liquefied into a liquid phase. It will remain as a gas. Can no longer, it is impossible to liquefy a gas at this critical point. Okay? So that is what meant by critical point. Okay, so now we look at the phase diagram. So this is the example of the phase diagram. So just now we look at this part where there are three components. There are three features dalam phase diagram: region, lines dengan points. Okay, so now let's look at the region. So there are three regions, right? This is the first region, solid, second region, liquid, and third region, gas. So this is the region. So this is, from this to this is the solid region. This to this is all the gas region, and this is a liquid region. Okay, so now line. So line kita ada. Okay, so for line, so this is the solid liquid equilibrium line, and this is the liquid gas equilibrium line, and this one here is the solid gas equilibrium line. So these three are the equilibrium line, where at this equilibrium line, solid and liquid are in equilibrium at same temperature, at same pressure. Okay, same goes to this. At this line, liquid and gas are in equilibrium, and at this line, solid and gas are in equilibrium. Okay, so and next we have points. So we have triple point here and critical point here. So triple point is where the solid, liquid, and gas exist in equilibrium, and critical point is where the gas can no longer liquefy into liquid, no matter how high the applied pressure is. So maksudnya kita dah tak boleh distinguish the gas ke liquid lagi lah. Okay, this is what critical point meant. Okay. Okay. So up until this point, we have learned about what is phase diagram, what are the components inside the phase diagram, and what is triple point and critical point, and we have learned on how to sketch the phase diagram. So untuk sketch phase diagram, first you have to have the x-axis and the y-axis. So the x-axis is pressure at ATM or kPa or any unit, but usually we use ATM, and temperature is at degrees Celsius, or we may use Kelvin, doesn't matter. And when we sketch the what we call it phase diagram, kita tak perlu ikut scale betul-betul. Okay, we just sketch it. Okay, so kita boleh, dia tak ada specific scale lah. Okay, kita just label je scale dia. Okay, dia tak ada specific scale ni. Tak perlu guna kertas graph. Okay, we don't need graph paper to sketch this phase diagram. And then first thing first, lepas kita buat tu, kita akan sketch this line ni, biru cair ni. Okay, kita akan sketch ni. And then depending on whether the solid is denser than liquid or liquid is denser than solid, kita akan tengok lepas ni, line solid liquid ni akan slope dia ke arah kiri atau kanan. Okay, let's look after this. Okay, but before that, kita akan tengok dulu phase diagram of water. Okay, so if we look at the phase diagram of water, this is how the phase diagram of water looks like. Okay, tadi saya cakap this solid liquid equilibrium line may incline to the left. Okay, which is negative slope, or may incline to the right, which is the positive slope. Okay, this one. Okay, bear in your mind this one. Patutlah tak dia. This one. This solid liquid equilibrium line. Okay, so this line here. So this line here is a negative slope. Kan? Dia inclined to the left. Okay, nampak ni dia inclined to the left. Okay, so kita akan tengok phase diagram of water. Kita akan discuss apa yang ada dalam phase diagram of water. First, kita identify phase diagram of water ni solid liquid equilibrium line dia incline to the left. Dia negative slope. Kenapa? Kita akan tengok lepas ni kenapa dia incline to the left. Kenapa phase diagram of water ni solid liquid equilibrium line dia adalah negative slope. Okay, kita akan tengok lepas ni. Tapi sebelum tu kita akan tengok dulu apa yang ada dalam phase diagram water ni. Kalau kita tengok dekat sini, kecilkan sikit ya. Okay, I hope you can still look, nampak kat sini. Okay, at temperature 25 degrees Celsius, kita akan nampak around sini lah, and 1 degree Celsius. So maybe around here. Okay, I would say around here. Okay, at 25 degrees Celsius, 1 atm. Around here, dia adalah liquid phase. Okay, so water at 25 degrees Celsius and 1 atm pressure exists as liquid phase. Okay, at room temperature lah kiranya kan. At room temperature, water exists as liquid phase. Okay, however, at temperature 0.01 here, at temperature 0.01 and at pressure 0.006. Okay, this is where the water component is at triple point. Okay, where the solid, liquid and where this water exists as solid, liquid and gas, the equilibrium line. Okay, this is the triple point. Okay, 0.01 degrees Celsius and at 0.006 pressure. Okay, atm pressure. Okay, at 374 degrees Celsius and at 218.3 atm, this is where the critical point for water is. So this means that no matter how great your pressure is applied to the gas, it can no longer be liquefied into a liquid phase. Maksudnya at this point, we can no longer distinguish the gas and liquid phase. Okay, and now we look into the at 0 degrees Celsius here, at 0 degrees Celsius and 1 atm here point. Here, this is the normal melting and freezing point. So at this point, the equilibrium line is at solid and liquid. This is where the solid may turn into liquid through melting point, through melting process, and liquid may turn into solid through freezing process. So this is the point where the melting point and freezing point are at. Okay, dia memang betul-betul dekat line solid liquid equilibrium line. Okay, next we have the boiling point here at 100 degrees Celsius and 1 atm. This is the normal boiling point, where at this point where the liquid will boil into gas. Okay, will enter the gas phase. Bila dia boil kan, dia ada vapor kan? Itu vapor tu dia enter gas phase. Okay, so this is boiling point here. Okay. Alright. So now we are going to explain why does this solid liquid equilibrium line of water phase diagram is inclined to the left, is negative slope. Okay, this is due to the anomalous behavior of water. So, let's see what is the non-typical phase diagram. So phase diagram of water ni dia tak typical lah, dia lain daripada yang lain, dia anomalous. Okay, kenapa? Okay, so let's see the explanation here. So it says that line of solid liquid equilibrium slopes to the left. It has negative slope. Why? It indicates that at high pressure, the melting and freezing point decreases. So at higher pressure, for this phase diagram, the melting or freezing point decreases because, okay, ice is less dense than liquid. Okay, ice solid is less dense liquid water. So it occupy larger volume. Sebabkan dia less dense, dia ada larger volume. Sebab apa? We know that density is equals to mass over volume. So, bila density lower, volume lagi besar. Betul? So, bila volume lagi besar, okay. So, at high pressure, it favors the formation of liquid. So, at high pressure, it favors the formation of liquid water which has smaller volume. So, disebabkan liquid ni dia ada smaller volume, dia lagi denser daripada ice. At high pressure, substance lagi tend to form liquid rather than ice. So, less heat is required to melt the ice. So, ice melts at lower temperature and at higher pressure. That is why if we look at this phase diagram, we can see that the slope inclined to the left. Maksudnya, region water ni, region liquid ni lagi besar daripada solid. So, we can say that it favors the formation of liquid rather than solid because liquid has smaller volume than solid. Sebab solid dia ada high volume sebab dia less dense. Miss ulas sekali lagi. Since solid is less dense liquid, it has larger volume occupied. So liquid has smaller volume occupied. So since liquid has smaller volume occupied, it favors the formation of liquid rather than solid. Sebab liquid ada smaller volume. Okay, so ice dia akan melt at lower temperature at higher pressure. Okay, so maksudnya lagi tinggi temperature dia. Okay, lagi tinggi temperature, lagi lower temperature dia, lagi apa? Lower temperature? Sorry. So, maksudnya, ice ni, dia boleh melt at lower temperature and at higher pressure. Tengok kat sini. Kita tengok kat line dia ni, Okay. Kita tengok dekat line dia ni, okay. So, maksudnya, makin dia ke sini, makin dia ke sini, bila makin dekat low temperature and high pressure, dia makin senang nak melt into water. So, dekat sini, kita boleh cakap yang water lagi water lagi favorable lah at this liquid phase rather than solid phase. Okay, alright, itu yang Miss nak cakap. Okay, so kalau awak nampak dekat sini, nampak tak dekat sini, at high pressure makin low temperature dia. Kalau awak buat line kat sini, dia pun temperature dekat below zero kan. So maksudnya ice ni dia boleh melt into liquid at lower temperature and at high pressure. Itu maksud dia. Okay, sebab tu dia less energy required, sebab tu dia favorable at liquid phase rather than solid. Sebab tu solid liquid equilibrium line dia inclined to the left, dia ada negative slope, which is rare. Dia tak typical lah dalam phase diagram. Phase diagram biasanya dia akan ke right, positive slope. Tapi water dia special case, dia ada negative slope, inclined to the left. Okay, alright. So now, okay, Miss harap boleh faham untuk part water ni. So now we are going to look at the phase diagram of carbon dioxide. Okay, so phase diagram of carbon dioxide, dia ada positive slope. Kalau kita tengok dia punya solid liquid equilibrium line, dia adalah positive slope. Maksudnya dia incline to the right. Okay, so dia adalah typical lah. Okay, typical phase diagram yang memang sepatutnya satu-satu phase diagram ada. Okay, kita tengok yang pertama. Kita tengok penerangan phase diagram untuk setiap point and setiap temperature dia. Okay, untuk carbon dioxide at 25 degrees Celsius here, around here, and 180 m around here. So dekat sini lah, around here. Okay, so around here, okay, it exists as vapor phase. Ada around here sangat, around here kot. Okay, it exists as vapor phase. So carbon dioxide ni dia memang dekat room temperature dia gas phase lah kan. Vapor phase ataupun gas phase. Tak ada pun kita nampak dekat room temperature ni ada carbon dioxide seketul, tak ada kan? Sebab dekat room temperature carbon dioxide dia exist as gas phase ataupun vapor phase. Okay, so now kita tengok at negative 56.4 and at 5.11 atm adalah dia punya triple point where carbon dioxide exists as liquid, solid and gas in equilibrium. Okay, at 31.1 degrees Celsius and at 72.8 atm, it is the critical point for carbon dioxide. Okay, at this point, the solid and liquid phase of carbon dioxide can no longer be distinguished. Maksudnya, gas cannot be liquefied into liquid phase no matter how great the pressure is applied. Okay, and next we have this S point. So this S point is where the negative 78.5 degrees Celsius and 1 atm is the sublimation or deposition point. So dekat sini where macam point di mana solid akan sublime into liquid or liquid akan solid akan sublime into gas, or gas akan deposit balik into solid. Okay, so dekat sini this point is on the solid gas equilibrium line and this triple point is on the solid liquid gas equilibrium line. Okay, so now kita nak tengok triple point of carbon dioxide. So triple point of carbon dioxide ni, if you look here, the triple point of the carbon dioxide is above 1 atm. Nampak ni? Kat sini kan? Dia punya triple point dia dekat 5.11 atm. Dia above 1 atm. So, kalau dia above 1 atm, apa maksud dia? So, maksud dia, solid carbon dioxide does not melt but sublime. So, maksudnya dekat 1 atm ni, dekat below 5.11 ni, okay, solid carbon dioxide dia tak akan pergi dekat liquid. Dia akan terus sublime into gas. And gas pun akan terus deposit into solid. Okay, when heated at 1 atm. So, solid carbon dioxide does not melt but sublime when heated at 1 atm. So, bila je liquid carbon dioxide boleh exist? So, liquid carbon dioxide only exists, okay, and stable at high pressure. Maksudnya above 5.11 atm. So, above 5.11 atm ni barulah dia boleh pergi kepada liquid. Barulah solid can melt into liquid. Other than that, below 5.11 atm, solid will directly sublime into gas. Okay, so as the temperature increase at constant pressure, it will solid will sublime into gas phase. Okay, this is the gas carbon dioxide punya phase diagram. So remember, disebabkan triple point of the carbon dioxide gas is above 1 atm. So maksudnya dekat 1 atm ni solid ni akan directly sublime into gas phase. Bear that in your mind. Okay, and bear juga dekat your mind yang the liquid phase only can exist above 5.11 atm. Dia boleh exist and stable above 5.11 atm je. Kalau tak, dia takkan exist lah. Okay. Alright. So now kita nak explain pula tentang typical behavior of carbon dioxide. Tadi anomalous behavior of carbon dioxide. Anomalous behavior of water. Sekarang kita tengok yang typical behavior. Maksudnya ini adalah typical phase diagram lah. Okay, so kalau kita tengok kat sini. Okay. So, line of solid liquid equilibrium slopes to the right. Maksudnya, dia ada positive slope. So, carbon dioxide dia ada positive slope. Indicate that at high pressure, the melting or freezing point increases. Okay. So, kat sini, kenapa line dia positive slope? Because solid carbon dioxide is more dense than liquid. So, bila dia more dense, kita tahu density is equal mass over volume. So, bila dia lagi denser, dia ada small volume. Okay. So, dia akan favor formation of solid. Okay. So, maksudnya, okay, senang cerita, sama ada dia incline to the left ataupun to the right, awak kena tengok dia punya density dia. Kalau density dia lagi rendah, maksudnya volume lagi besar. So, kalau volume lagi besar, dia akan, dia tak favor ke arah solid. Dia lagi favor ke arah liquid. Okay. Tapi, kalau slope dia, kalau dia punya solid tu lagi, kalau dia lagi more denser. Okay, kalau solid carbon dioxide ni more denser, dia occupy smaller volume. So, dia lagi favor untuk form solid. So, line tu akan ke arah kanan. Sebab dia nak bagi besarkan lagi region solid tu. Okay, boleh faham So, dekat sini awak tengok. Disebabkan solid carbon dioxide is more dense and they occupy smaller volume than liquid carbon dioxide. So, it favors the formation of solid carbon dioxide which has smaller volume. So, dia akan favor smaller volume. Okay, dia akan favor smaller volume. Dekat situlah arah slope tu akan incline tu. Okay. So, bila dia lagi, so kenapa dia lagi favor formation of solid carbon dioxide yang ada smaller volume? Sebab apa? More heat is required to melt the solid carbon dioxide. So, solid carbon dioxide will melt at higher temperature and at higher pressure. So, note kat sini, substance yang ada higher density dekat solid phase, biasanya dia akan show similar phase diagram macam carbon dioxide. So, clue dia awak nak tahu line dia incline ke kanan atau kiri, awak kena tengok solid dia less dense ke more dense. Kalau less dense, dia akan ke kiri, dia negative slope. Kalau solid tu more dense, dia akan ke kanan, positive slope. Itu je. Okay, ingat tu je. Okay. So, itulah dia punya. So, kalau awak tengok kat sini, so, kalau tengok kat sini, at high pressure, dia punya melting dengan boiling point dia akan lagi tinggi. Nampak So, ini kan dia punya melting and boiling point punya line kan. Solid liquid equilibrium dia, solid liquid equilibrium line dia di mana solid akan pergi kepada liquid akan pergi kepada gas. Solid liquid akan pergi kepada solid. So, dekat sini makin tinggi at high pressure, dia punya melting dengan freezing point dia makin increases. That is why. Okay. Alright. So, kita dah bincang pasal kita dah tengok phase diagram of water and carbon dioxide, and kita dah explain dah tentang phase diagram for both component. So, now kita nak tengok the changes in phase of a substance. Okay. So dekat sini kita ada dua phase changes yang kita akan tengok. First, kita akan tengok the changes in phase with respect to the temperature at constant pressure. Yang pertama ni, at constant pressure. At constant pressure, which is kita panggil isobaric heating. Maksudnya, kita increase temperature by at constant pressure. Okay. Dekat sini actually dia ada dua, tapi saya bagi contoh satu je. Okay. So dekat sini, kalau kita tengok nombor satu, daripada solid ke liquid ke gas phase. Okay, if you look at here, dia kata kat sini, when a substance is heated at constant pressure, okay, constant pressure tapi temperature increase kan, solid reaches solid liquid equilibrium line. So solid reaches solid liquid equilibrium line and changes to liquid phase. Okay. Bila dekat liquid phase, upon further heating, liquid will reach the liquid gas equilibrium line and finally change into gas phase. Okay, ni yang pertama. Okay, boleh juga dia jadi macam ni sayang. Okay, daripada sini pergi sini kan. Daripada sini pergi sini. Ini pun dikira isobaric heating. Okay, di mana temperature increase tapi pressure constant. So, kalau dia punya penerangan dia adalah solid reaches solid gas equilibrium and changes into gas phase as the temperature increase at constant pressure. Tu pun boleh juga. Okay. So, ni pun samalah untuk explanation yang pertama. So, ni kira yang pertama jugalah. Okay. Tapi explanation dia lainnya. Yang ni cuma involve solid dengan gas saja. Okay. Kita tengok yang kedua pula. Yang kedua bila when a substance is compressed at constant temperature. Maksudnya temperature dia sama tapi pressure dia berkurang. Okay. So, dekat situ kalau kita tengok, yang pertama kita ada nombor 2 ni. So, when gas is compressed at high temperature, at constant temperature. Okay. So, dekat sini kita boleh nampak gas dekat sini dia akan reach betul lah. Saya salah baca. Saya baca yang ini. Patutlah saya pelik. Yang ini, okay. Allah, kenapa Okay. Ini. Okay. So, dekat sini. Okay. Yang nombor 2 ni. Alright. The gas is different pressure at constant temperature. So, dekat sini kalau kita tengok. Ini kita increasekan dia punya pressure. So, pressure dia naik. Okay. Bila pressure dia naik. Solid ni. Dia akan reach solid gas. Gas ni dia akan reach solid gas line equilibrium line and finally change into solid phase. Okay, this is for deposition lah kan. Kalau sublime compress lah, dia boleh vice versa. Okay, dia boleh vice versa. Yang nombor 1 ni pun sama, vice versa lah. Okay, sama ada dia lowkan temperature dia at constant pressure ataupun dia heat temperature at constant pressure. Yang nombor 2 ni sama ada dia compress ataupun dia increase the pressure at constant temperature. So, in this case, dia increasekan pressure dia lah at constant temperature. Gas akan makin lama pergi ke solid phase. Boleh juga dia daripada sini ke sini. Maksudnya, okay, when a substance is compressed at constant temperature, okay, the liquid will reach the liquid gas equilibrium line and finally changes to the gas phase. Pun boleh juga. Okay. Awak kena tengoklah, awak kena baca graph awak sendiri, phase diagram awak sendiri. Baca dia at constant pressure ke, at constant temperature ke, mana yang bertukar, temperature dia increase ke, temperature dia decreases ke. Semua tu awak kena baca sendiri. Okay, tapi this is how you explain the phase changes in a substance by using the phase diagram. Okay, so now kita dah habis untuk 5.4 phase diagram. So what are we going to do now is we are going to look at the tutorial question. Okay, Miss tak sempat nak explain semua tutorial question. But untuk tutorial question yang lain, apa yang Miss boleh buat adalah kita boleh bincang, Miss boleh buat a new short videos to explain sikit pasal soalan tutorial tu Okay, tapi yang untuk tutorial kali ni kita akan bincang 3 soalan saja. Okay, so now kita tengok tutorial question 1. Question 1 asks you define phase. Okay, define phase ni boleh tengok dekat dalam lecture slide ataupun notes dalam video ni. Okay, and then soalan nombor 2. Dia kata state the number of phase for each of the following system. Okay, molten salt. Okay, molten salt ni maksudnya salt yang dah dicairkan. So, kalau salt tu dah dicairkan, agak-agak apa fasa, apa phase yang exist dekat molten salt ni? Ada berapa fasa? Ada satu fasa saja, betul? Ada satu fasa saja. Apa dia? Liquid phase lah kan, betul? Okay. And next, kita tengok. State the number of phase untuk salt water system. Okay, salt water system. If all the salt dissolve in water. So, kalau semua salt dah dissolve in water, no more salt. No more solid. Semua dah jadi liquid. So, ada berapa fasa yang ada? How many phases are there in the system? Only one phase, which is liquid phase. Okay, however, dia ada, what about bila dia ada excess of salt? Maksudnya akan ada solid dan akan ada liquid. Betul. So, ada how many phases are there? Ada 2 phases. Okay, how about if the system is heated under sealed condition? So, bila dia heated, okay, salt water bila heated, dia akan jadi warp, betul tak? Dia akan boil. So, dia akan jadi warp. Kat situ ada vapor molecule dekat situ. Maksudnya dia akan exist as liquid and vapor. So, ada how many phases are there? 2 phases. Okay, now let's look at C. Mixture of oxygen gas, nitrogen gas and carbon dioxide gas. Semuanya gas. Maksudnya dia ada satu fasa saja, which is gas phase. Okay. HNO3 aqueous in equilibrium with its vapor. Ada 2 fasa, which is liquid and vapor. So, ada 2 fasa kat sini. So, dekat sini, this is the answer for this question number 2. Okay. Question number 3A. Dia kata define critical point and triple point. This one also ada dalam slides note and dalam nota video ni. So, kita akan tengok terus ke question B. Okay. Question B. Okay. Dia kata the normal melting and boiling point of sulfur dioxide is 200 Kelvin and 263 Kelvin respectively. So, this is dia punya melting point. This is dia punya boiling point. So, its triple point temperature is 198 Kelvin. So, this is dia punya triple point. And the triple point pressure is at 1.7 times 10 negative 3 atm. Its critical point is at 430 Kelvin and 78 atm. Ni critical point dia. So, solid sulfur dioxide has a lesser volume than liquid sulfur dioxide. So, maksudnya apa? So, dia ada lesser volume. So, maksudnya solid SO2 is denser than liquid SO2 kan. So, bila denser, dia punya key point dia denser kan. So, bila dia denser, slope dia akan slope positif. Pergi kepada right kan. Kalau solid dia less dense, dia akan ke kiri macam water. Tapi sebab solid dia denser dan liquid, so slope dia akan kepada positif. So kita tahu dah tu kan. Okay, next dia kata sketch. Soalan dia suruh sketch the phase diagram of SO2 and state how SO2 gas may be sublimed directly to solid SO2. Okay, ada beberapa point. First kita kena sketch dulu phase diagram. So kita nak sketch phase diagram. Okay, first kita kena ada line pressure dengan line temperature. So dekat sini kita label this is the pressure. This is the pressure. Mesti label serta exist at ATM. Okay, tengok ATM betul kan? Okay, and then temperature dia at degree Celsius ke Kelvin? Temperature at Kelvin. So, Kelvin. So, kita nak lukis pula dia punya yang macam punya bonggol tu kan? Okay, kita lukis dulu bonggol-bonggol dia macam ni. Macam ni. Okay, lepas tu macam ni. Okay, tak buruk sangat pula. Okay. So, sekarang kita tahu solid SO2 lagi denser. So, slope dia positif. So, kita akan buat slope dia ke arah positif, ke kanan. So, kat sini, ini adalah solid liquid gas tu kan? Solid liquid line, equilibrium line dia kan? So, slope dia ke arah sini. Okay. So, sekarang kita kena label. Okay, kita kena label triple point dengan critical point dia. So, kita label dekat sini. This is dia punya. This is dia punya triple point. Triple point T. And this is critical point C. Okay, dan kita nak label dia punya pressure dengan dia punya temperature. Okay, so kita nak label mana dulu? Label mana lah suka hati. So kita label lah dulu triple point. So triple point kita label dia punya pressure dengan temperature. Okay, label triple point punya dekat sini. Triple point punya pressure apa? 1.7 times 10 to the power of negative 3 atm. So, label. Dekat sini adalah 1.7 times 10 to the power of negative 3 atm. Oh, tak. Okay. And then, kita label pula dia punya temperature triple point adalah berapa triple point punya temperature? 198 Kelvin. Okay. Now kita label temperature dengan pressure untuk critical point pula. So critical point punya pressure. Okay. So critical point punya pressure is at 78 atm. So kat sini adalah 78 atm. And dia punya temperature dia adalah at apa ni? 430 Kelvin. Okay. 430 Kelvin. Okay, sekarang dia bukan bagi kita triple point dengan critical point saja. Dia bagi kita juga dia punya melting dengan boiling point. So, melting dengan boiling point ni biasa ni dekat 1 atm. So, kita akan label dekat sini. Maybe kat sini adalah 1 atm dia. Okay. So, bila kita label tu 1 atm dia, kita nak cari dia punya melting point dengan boiling point dia. Okay. So, ini adalah 1 atm. Kita label terus sampai capai yang ini. Okay. Dah sampai liquid, solid liquid line dengan liquid gas line ni. Pergi kat temperature bawah ni pula. Okay, so kita label pula dia punya point dekat sini. So, ni adalah dia punya melting point ni adalah boiling point dia. So, nanti kita kena label, okay? Alright, so kat sini adalah 1 atm. Okay, temperature dia. Okay, kita pergi temperature untuk ni pula, melting point ni. Okay, temperature untuk melting point adalah berapa tadi? 200 Kelvin. So, 200 dekat sini. Okay. And temperature untuk boiling point 263. So, ini adalah 263 Kelvin. So, boleh label dekat sini. Ini adalah melting point. Ini adalah boiling point. Okey, kenapa Miss tahu dia adalah 1 atm? Sebab dia bagi hint normal. So, normal melting dan boiling point adalah pada 1 atm. Okey, so inilah macam mana you sketch you punya graph, phase diagram. First, lukis dia punya axis dulu, pressure dengan temperature and label. Second, lukis dia punya lingkungan tu dengan. Third, awak tengok solid liquid line dia tu. Tengok dia solid dia denser ke less dense. Kalau denser dia punya slope positif kan. So terus lukis slope dia. Next, awak label dia punya pressure dengan temperature of critical point. Pressure dengan temperature of critical point. And then awak label dia punya pressure dengan temperature of melting dengan boiling point. That is how you do the sketch the phase diagram. Okay, kita ada one more question. Dia kata apa? State how sulfur dioxide gas may be sublimed directly to solid sulfur dioxide. Okay. So, kalau awak tengok, dia boleh sublime kalau dia punya pressure dia less than. Okay, kalau awak tengok kat sini, kalau pressure dia less than 1.7 and then temperature dia less than 1.98, dia boleh turn from solid into liquid. Betul? Am I right? So, dekat sini awak boleh cakap SO2 gas may be sublimed directly to solid sulfur dioxide by cooling it to a temperature of less than 198 Kelvin at a pressure of less than 1.7 times 10 negative 3 atm. So this is how you sublime the gas into to solid. Okay. Kalau dia temperature less than 198 dan kalau pressure dia less than 1.7 times 10 negative 3 atm, dia boleh sublime daripada solid to gas and gas to solid. Okay, directly without pergi kepada liquid. Okay. So, kita dah jawab soalan nombor 3B. Okay, sekarang kita nak jawab soalan nombor 3C. Okay, if we look at question number 3C, lebih kurang je macam soalan tadi tu. Okay, let's do this together. Dia kata, substance X has its triple point at 180 degrees Celsius and 0.5 atm. Okay, the melting point and boiling point are 20 degrees Celsius and 200 degrees Celsius respectively. Sketch the phase diagram for X. Sama juga. First step, kita kena lukis axis dia. Sebab nak lukis phase diagram kan? Okay, so this is pressure. So this is pressure at atm. And now the temperature is at degree Celsius punya unit. Okay. Alright, so second kita buat dia punya bonggol-bonggol tu. Okay. Okay, dia tak cakap pasal denser ke less dense ke kan. So, kalau normal yang dia akan positive slope. So, kat sini positive slope. Okay. So, this way kita label triple point dia at 180 degree Celsius and 18 degree Celsius and 0.5 atm. So, kat sini adalah triple point T. So, kita label dia punya pressure dia kat mana dengan ni. So, kat sini. Excuse my, what we call it, buruk punya tulisan. So, kat sini kita label 0.5 atm. Temperature dia 18 degree Celsius. Now, dia kata the melting point and boiling point are at 20 degree Celsius and 300 degree Celsius. So, dia punya so, kat sini dia punya what we call it, kita nak tengok dia punya melting dan boiling point dia. Kita cakap ini, so inilah dia punya 1 atm. Okay, so kita buat macam ni. Allah. So, kita label. So, ini dia punya ni dia punya melting point dia. Okey, teruskan lagi. Ini adalah dia punya boiling point dia. So, awak label dekat sini. So, ini adalah 1 atm. Okey, so dia normal boiling point. So, kat sini dia punya melting point dia adalah 20 degree Celsius and boiling point dia adalah 300 degree Celsius. Okay. Nah. Hilang. Okay. So, dekat sini awak label lah. Ni boleh label lah ni melting point. Ini boiling point. And awak lupa lagi satu, awak kena label ni. Awak ni. Label ni adalah critical point C. Okay, dia tak bagi tahu pasal C kan. So, tak payah buat apa-apa lah. Cuma awak label je critical point. Sebab apa? Critical point dengan triple point wajib label pada setiap phase diagram. Okay. And kat sini awak boleh label lah. Dekat sini adalah dia punya apa ni? Melting point. Ataupun awak buat je label je macam M ke macam tu ke. Yang ini adalah dia punya boiling point. Label lah B ke apa ke. Okay. So, semua kena label. Okay. So, kat sini awak check balik betul tak? 1 atm, 20, 300. Okay, semua betul. So, this is how you sketch the phase diagram for substance X. Very simple and very easy. So, now, kita nak so, saya harap awak dah faham untuk chapter ni. Okay, harapnya lah. Okay, kalau tak faham, ulang balik video tadi. Ulang balik video ni. Okay, sebelum apa-apa, tolong jawab quiz chapter 5.4 ni sebab saya ambil attendance. Okay, so wajib jawab. Okay, sebab simple je soalan dia. Okay, alright, so that's all for today. Video kali ni panjang sikit sebab banyak benda nak kena cakap dalam phase diagram ni. So, yeah, that's all for today. Thank you. Bye-bye. Assalamualaikum.